Hi, hello, this is Amita. Today we are going to see about double linked list. That means insertion and deletion of nodes at the end and beginning of the double linked list. Here we can go into the program. First, we have a standard input and output library, a header file, and also we have a standard stdlib.h. This is basically for using mloc keyword, which basically allocates memory for the node. Now initially I am declaring a struct name node and declaring a struct name node and also a two pointer variable name previous and next, and then an integer data type variable called data. This will be storing the data which we give input to the nodes, and I also have a pointer name head which of the type struct node. And next what we are going to do is I have 5 functions. The first is insert beginning. Insert beginning, where we are going to insert a node at the beginning of the function, and then insert last, where we insert a node at the end of the function, and then followed by delete beginning and delete last, where we are going to insert delete at the beginning of the function and delete at the last of the function. And the last is display, for displaying all the elements of the double linked list. First we start with the void main, and here we have an integer data type called choice. We are going to use this for choosing an option from the menu. We are displaying at the beginning, and then I'm using a while condition to choose and equating to for choice and equating it to not equal to 6. So first I have a printf statement menu. Inside that I have another printf statement called choose an option. What those are: insert in beginning, insert at last, delete at beginning, delete at last, and display. Then we have a printf statement, enter your choice, followed by that a scanf statement to get the input, and then I'm giving I have a switch case for the variable choice. Basically for case 1, we call the function insert beginning, where I initially declare globally here. And if the user gives any other input continued, followed by case 2 insert at last, and case 3 delete at beginning, and case 4 delete last, case 5 display for displaying the elements. And if the user gives any other input or choice apart from these 5, I have given a default statement which will print please enter a valid choice. And then we can start the program. Now we are going to define the 5 functions that we have mentioned previously. Start with the insert beginning. This is the function going to return me nothing, so I am starting with the void insert beginning, followed by a parenthesis. Inside that I have a pointer p and an integer data type item. As I told earlier, this item is going to store the data that user is giving to the node. So what I'm doing next is variable p actually allocating a dynamic memory allocation which is of the size of the struct node we declared initially. So the dynamic memory will be allocated of the size of the struct node that will be stored in the address of p. And the first thing I'm checking is that the pointer is equal to null, that I have initially declared that pointer is equal to null. If that is the case, I'm printing it as overflow. And else here we are coming to the main part of the program. So here is the else statement. I have another if and else statement. In the else statement, I have a print statement where called I printed enter the item value to get the data, and then followed by the scanf statement to get the input. input, and then I have a if statement and checking that head is equal to null. There is two cases in this in this case, two cases. In the first case is either the linked list is empty, that's what here we mentioned, that head equal to null. So if the head is the pointer that points the first node of the any list, if head equal to null means that there is no data or node in the double linked list. In that case, the node we are inserting will be the first, so that I'm first assigning null for both the previous and next, and then I'm assigning item to the p of data, and then I'm assigning p equal to head. Then else we are using this condition. If this condition is true, in this case we will print node is inserted. And next we are going to see about insert at last. Here we are initializing a pointer variable p and also a temporary variable, and then an item of data type integer, and then a p actually allocating a dynamic memory allocation which is of the size of the struct node we declared initially, so that the dynamic memory will be allocated of the size of the struct node that will be stored in the address of p. What we actually saw at the previous function. And then we are giving a if statement with a condition of p equal to null. If the case is true, we print it as overflow, else we will give a printf statement as end item value, and then followed by a scanf statement to get the input, and then we are assigning item to p of data, and then again we are giving an if statement with a condition head equal to null. Here we are going to check that there is any node at the function, and then here also we are assigning null to both the previous and next, and assigning p equal to head. Else I'll be using a while statement which says as temperature of next is not equal to null. Basically what the while loop does is it travels till the last element of the double linked list. That obviously the last element next address will be null. That is the condition we have here, that temperature of next is not equal to null, and then followed by this condition. If this condition is true, in this case we will print as node inserted, and then we will see about delete at the beginning, initializing a pointer variable p. Then we have a if condition as head equal to null, that we are checking that there is any node in the any node in the function. If there is not any node in the double linked list, we will print as underflow. Else we will check that head of next is equal to null, that we will check that if there is any one node at the double linked list. If there is one node, we will delete it, and there will be no nodes, and at the last we will free the memory allocator for the head pointer, and if the node is deleted, we will print as node deleted. Else if there is n number of nodes, we will follow this condition and assign head to head of next and null to head of previous, and at the last free the memory allocator for the head pointer, and if the case is true, we will print as node deleted, and then we will go to the next function, delete at last. Here also we are initializing a pointer variable p, and then we are checking that there is any node at the double linked list with the condition head equal to null. If the case is true, we are printing it as underflow, and next as same what we did in the last function, we are checking that there is any one node in the function, and it will be the last node in both first and last node, so we'll be deleting it, and at last we will free the memory allocator for the head pointer, and if this case is true and the node is deleted, we will print as node deleted, or else if there is n number of nodes in the double linked list, we have to select we have to select that the last node have to be deleted, and we follow this condition. If this condition is true, we will print as node deleted. And the last function, next we are going to see about the last function as function display. In this display also we are initializing with a pointer variable p, and followed by a printf statement of printing values, and then we are assigning head equal to p, and we are using a while statement that p is not equal to not equal to null, and printing that p of data, and then we are assigning p equal to p of next to display all the elements we want to display. That's it. Now we can run the program. It is asking enter your choice. Enter a choice. The 5 choices are insert in beginning, insert at last, delete at beginning, and delete at last. We can see from first. We will first enter it. Give insert in beginning. It is asking for data. We will give us 25. Node inserted. Then we can insert a data at last, so we'll choose 2. Then value will be we can give it as 85. It says the node is inserted. Okay, then we will see the nodes which are inserted, so we will give the choice 4. So sorry, it's deleted last. We want to display it, right? So we will give the choice 5. Printing value is 25. 85 is not printed, as I deleted above that. I gave 4, is it? So the node is deleted, so it is printing the value as 25 only. Now we can give the choice as 1. We can enter a value at first, so now here we can give 45. Then we can enter a value at last. Choice 2, we will enter a value 65. Then now we can display it. It's displayed as 45, 25, 65. Now we can see how it's deleting. Now we can give a choice 3. Choice 3, no deleted. Then we can now we can display it and see the first number is deleted. Now we can give it deleted last. 4, not deleted. Now we can display it. See, the last element is deleted. That's it. Thank you. That's it. I hope you understand this program.